The margin of error denoted as E can be used to determine the minimum sample size needed to construct a confidence interval. So E, if you recall, is equal to z sub alpha over 2 times sigma divided by radical n. Well, we want to estimate n. What we can do is we can use some algebra to solve for n. If we do this, we'll end up with the following formula. N is equal to 7 sub alpha over 2 times sigma divided by E, quantity squared. And when we calculate n, we must always round it upwards. So round the final answer up to the nearest whole number. So this is the last part of section 7.1. There's only a few problems, but they do pop up every so often on quizzes and tests. So you want to be careful and be aware of what you're looking for. So let's take a look at an example and then decipher when to use this formula. So compute the minimum sample size. So right there, that's our clue. We want to calculate the minimum sample size, that's n, needed to construct a confidence interval for the true mean of late arrivals to math class. The population standard deviation is 0.55 late arrivals, and the margin of error is 5%. The confidence level is 95%. So remember, using our table, if we look up 95%, that tells us that z is 1.96, the standard deviation is 0.55, and the margin of error is 5%. That's another way of just writing 0.05. So we're going to divide by 0.05. So we multiply these two numbers in the numerator, divide by 0.05, and then finally square 21.56. The last step is we have to round upwards to 465. So the minimum sample size would be 465. And then there's a few problems for you to try. So I'll let you go ahead and try these problems. And we're now officially done with section 7.1.